magnetic field due to a bar magnet at equatorial point. We have considered a bar magnet of distance 2a, because half distance is a and another half distance is a, and the total distance between this south pole and this north pole is 2a. So, and I want to find the magnetic field due to this bar magnet at equatorial point, say point P, which is at a distance of x from the center of this bar magnet, right? And the distance from the pole of the bar magnet to this point is r and r. So both the distances from north pole and south pole to the point P, this point P is same. Let the angle between this bar magnet and this line is theta. This is also theta. So angle between this line and this bar magnet is theta here, and there is also theta. So at this point, the magnetic field, I want to find the B magnetic field. B net equal to how much? So first of all, let us see the directions of magnetic field due to south pole and north pole at this point P. First, for north pole, and we know that from north pole the magnetic field lines are going out. Okay, at each point it is going like this, it is going like this, it is going like that. So therefore at this point the magnetic field is going this side, away, going out from the north pole. So this is the magnetic field due to north pole. So this is B N. Okay, you should always remember this is B subscript N, not the B N. Okay, so this N is in subscript. So the magnetic field is going along this line, that is B N. Now for south pole, we know that at south pole all the magnetic fields will come and go into the south pole. Okay, so at this south pole, from this point the magnetic field is going towards the south pole. So this is BS. Okay, B vector S, because of south pole. And this M and this M, small letter m, are the pole strength of this bar magnet. Okay, magnetic strength, or we can say pole strength. So we consider a dotted line which is parallel to this bar magnet. Then if it is making, this is like this, if it is making angle theta, say 30 degree, and if I do like this here also, then this angle should also be 30 degree. It means that if it is 60, then this is also 60. Then if it is theta, then this angle is also my theta. Similarly, if it is theta, then this angle will also become theta. Okay, by the geometry. And I want to find the net magnetic field. So there are two ways to find the magnetic field here. That is by using the vector addition, that is r equal to under root a square plus b square plus 2ab cos theta. The another is to use the resolution of vector. Okay, so we are going to solve it by using resolution. So I have considered one vector, this is Bn vector. If I want to resolve this, I have to resolve it in two vectors, that is one is my horizontal vector. So this is horizontal vector and one is which vector? Two vectors. There should be two vectors. One is horizontal and one is vertical. So this is my horizontal. So this is B horizontal. So the script, and this will be my, this will be, okay, not here. From there, this will be my B vertical. Okay, isn't it? So I will do like this. I will make a right angle triangle, and this is my theta. It means that there are two components. One is, what is one? One is my vertical component. So this is my B of vertical, and there is one horizontal component. So I will drop this out. I will mark it with this one. There is one this component. This is my B horizontal. Okay. So this this is the angle. It is very simple. Now I want to tell you one thing, that I am making this a little bit tilted one because there is another horizontal magnetic field due to this one. That is why I am doing like this. Okay, so this is my BH. Similarly, I have another vector, this vector. So this is my this vector, this is my BS, and this is my dotted line, and here dotted line, and this is my angle theta. Here also I will draw a line, this as BV, and this as not this as my this one. Okay, what is this? This is BH. It means that from this point there are how many BH? There are 2 BH. So 2 BH vectors. This I will draw here and make like this. So this is B horizontal magnetic field, and similarly there is one vertical. This is one vertical. This is B of vertical vector. Okay, so this vertical is because of this Bn, and this vertical magnetic field is because of this, and these two are because of this and this. Okay, so now if you see here, okay, BV and BV both are the vertical components of magnetic field, and which are in opposite direction with the same magnitude. Therefore they will cancel. Let us see first. So let me find how much is BH and how much is BV. Okay, let me find cos of theta. Cos theta is cos le bukera medium. Okay, then if you keep this triangle, what is base? So this is my base. Okay, and this is perpendicular. This is my base. Opposite to perpendicular is hypotenuse, and this is my perpendicular. So cos theta equal to base by hypotenuse. Now this is my base, this is my base, and the value of base is BH. So this is equal to BH divided by hypotenuse. How much is the hypotenuse? This is my hypotenuse, which is my BN. So this is my BN, and I want to find the value of BH here. So therefore you bring cos of theta is equal to BH by BN, or you bring this here, this BN will come here, and cos theta is there equal to BH. So I got BH equal to BN cos theta. So this is equal to how much? This is BN cos theta. Okay, we got BN cos theta as BH. It means that this is also BH, then this will be also my B. This blue is because of BS. This red is because of BN. So this will be BS cos theta. Okay. Now let me go to the vertical. For vertical, I will use sin theta. Okay. So then this is my sin of theta. Searching for pad arrival. So which is equal to perpendicular. Which is my perpendicular? This is my perpendicular. And this perpendicular is equal to PV, isn't it? This is equal to this. So this will be my BV. Okay. So this perpendicular is equal to this. So BV, and hypotenuse is this one, and this hypotenuse is which one? This is BN. So this is divided by BN, or I get sin theta is equal to BV by BN. Now I want to find what I want to find. I want to find BV. So then you bring this BN here. This BN is equal to this. Not BN. If you bring it BN here, there is sin of theta will be equal to BV. So we got BV is equal to BN sin theta. Similarly, this BV will be also BS sin theta. Why BS? Because this BV is because of this BS. So this will be BS sin theta. Okay, and you don't need to solve all this in examination. Okay, you solve it at the side of your page so that you can understand how these things have come. Okay, so these are very not important. You can just remember this is Bs sin theta, Bn sin theta. Okay, like this. So this is done. So we got this. Now if you see here, this is also Bn sin theta, this is Bs cos theta. Okay, so let us find how much is Bn, how much is Bs. Okay, now we know that B is equal to mu naught by 4 pi m divided by r square. So this is our formula. So therefore, how much is Bn? Bn will be equal to, I will write K, okay, as this mu naught by 4 pi is in K, and this is m divided by r square. So I am doing for Bn. So r square is the distance from this pole to this point, and this is my r. So r square will be equal to how much? How much? This is hypotenuse, this is perpendicular, this is base. So we know hypotenuse square is equal to perpendicular square plus base square, and hypotenuse is my here r square, okay, and perpendicular is x square plus base is minus a square. So this will be x, okay. Then r square is x square plus a square. So here I will write x square plus a square. Okay. Similarly, b of s is equal to, again this is same. Okay, this is r. So I will write k m divided by x square plus a square. Same thing. X square plus a square. Now if you see here, you write where k is equal to mu naught by 4 pi. Now if you see here Bn is equal to Bs, isn't it? This and this are same, which is equal to k m divided by x square plus a square. So they are same. It means that this Bn and this Bn and Bs is same, and there is sin theta and sin theta. So they become equal. This Bb and this Bb will become equal because this Bn, this is Bs, both are same, and if it is sin theta, this is also sin theta. Okay. So you write here, therefore the vertical components, that is BVs, are equal and opposite with each other. So they are equal and opposite with each other. Thus they cancel each other. So the net magnetic field due to the vertical components is 0. Okay. So therefore magnetic field due to vertical components is 0. Okay, is 0. So okay, so I will log this out and 0. So I will write here, we have done like this, Bn is equal to Bs, which is equal to k m divided by x square plus a square. We have done this. Okay, but below this, right? But the point P. But the horizontal components, that is BH, are in same direction. Thus, they can be added to get the net, that is B net magnetic field at point P. Okay, so these two are cancelling. No no magnetic field due to this vertical, but these two are in the same direction, so we have to add this. Okay, so then what we do? We do this thing. We do this thing. So therefore B net is equal to, this will be Bn cos theta plus Bs cos of theta, and this is equal to, how much is Bn? This is Kn by x square plus a square cos of theta plus what is Bs? Again same, Km divided by x square plus a square is also Bs, because Bs and Bn equal, and there is cos of theta. So we got this one. Now if you see here, this and this both are same, isn't it? So what I can write, this whole term and this whole term are same. 1 plus 1, 2. So this will become 2, and what is here? Km divided by x square plus a square and cos of theta. Okay, so let us now find the value of cos theta. So this is my B net. Now we know cos of theta is equal to cos le Bokera here. Now here we use the big triangle. Okay, we use big triangle. Big triangle here, this triangle or this triangle. So this is cos theta, which is equal to cos le Bokera here, which is equal to, what is base? Base is my A. Here this is my base. A, hypotenuse is R. So this is my cos theta. So which is equal to, therefore cos theta is equal to A divided by R. Okay. Now what we can write then this B net is equal to, okay, K is there, 2m I am writing here, divided by x square plus a square, and there is a divided by divided by r. Now what is the value of r? You know this, then this r will be how much? This r will be equal to x square plus a square under root. Okay, then this r is equal to x square plus a square. Under root means 1 by 2. Okay, so then this can be written as k is there, that is 2ma divided by, what is there, x square plus a square, and what is a, I bring it here. Okay, and what is the value of r? Is x square plus a square and 1 by 2. Right? Now this is x square a square, this is x square a square, both are same. Then if you have a into a, or a to the power 2, then this will become a to the power 3. Why? Because in multiplication, if they are same, the powers will be added, because I have here 1 and 1 plus 2 is 3. So similarly what I can do is, let me now put the value of k. This is mu naught by 4 pi, and 2ma is, you know, okay, electric dipole moment is Q2A. Okay, Q2A, and magnetic moment M is also M2A. So here is M2A. Okay, M2A. So this can be written as magnetic moment divided by x to the power 2 plus a to the power 2 whole to the power how much? 1 plus 1 by 2 will give me 3 by 2. Because there is 1 plus 1 by 2. We have to add the powers. Then this will become 2 plus 1 divided by 2 equal to 3 by 2. Taking the LCM. Okay. So this is done. And this is B net. Now we are done. Okay. So you have to write over here. M is equal to M, small letter m, to A, bracket में लिखो magnetic moment, mag magnetic dipole moment. Both are same. So we got each and everything. So let me write it here. So finally we got B net. B net is equal to mu naught by 4 pi m divided by x square plus a square to the power 3 by 2, or B net vector is equal to mu naught by 4 pi m vector divided by x square plus a square to the power 3 by 2. Okay. Now for very short bar magnet, this bar magnet you can also call this as magnetic dipole, because I have got two poles of the magnet. Okay, now for short magnet, or this magnet can be also as magnetic dipole. Okay, so both are same, magnetic dipole or magnet. So then if it is very short, then what will happen? This A will become much lesser than x. Isn't it? This point, this distance is my x. Okay, and this is my A. If it is very short, then this A will become much less than x. Then A square is almost equal to 0 as compared to x square. Okay, if A is very small, then x square is very large, then A can be treated as 0. Okay, if you have 1000 rupees, if this is 1000 and if it is 1, then 1 is almost 0 in front of x. Okay, or 1000. So therefore, for very short, what do I get? This is B net is equal to, there is mu naught by 4 pi, that is m divided by x square plus 0, because a square is 0, this is 3 by 2. Now in the next step, what will I get? I will get 0 as nothing to the power 3 by 2, and the powers will multiply. 2 into 3 divided by 2. So this 2 and this 2 will cancel, and what do I get? I get B net is equal to mu naught by 4 pi m divided by x to the power 3, or this B net is equal to vector form mu naught by 4 pi m vector divided by x cube. So this is the magnetic field for short. What do I get? This B net is equal to mu naught by 4 pi m vector divided by x to the power 3. We got this one, the net magnetic field for short and for long. Now what is the direction of net magnetic field? If you see here, what is the direction of magnetic moment? You have this magnetic moment. Direction is from south pole to north pole. Okay, it is from south pole to north pole. It means that the direction is from south pole to north pole. That is, this is south pole and this is north pole. This is the direction of magnetic moment. Please draw this. Okay. Now, what is the direction of net magnetic field? The net magnetic field is coming in this side, which is opposite to the direction of magnetic moment, because magnetic moment is in this direction, the net is in direction. So therefore the direction of net magnetic field is opposite to direction of magnetic moment. Okay, you have to write this. Why? Because magnetic moment is from south to north, but in opposite to this magnetic moment. So this is the important and useful derivation. Thank you.